my name is Bindu Reddy. I'm the CEO of Abacus.AI. I'm here to talk to you a little bit about generative AI, as well as how Abacus fits into that equation. So let's just dive in. I'm sure you guys have all, heard about ChatGPT, and then the buzz about Gen AI just won't stop. It has taken off in a really, really big way. You can come up with any type of use case, any department, what have you, there is a Gen AI company for it right now. Lately, you see most VCs also focused on some Gen AI segment or the other. So everything from marketing to sales to HR to legal, people are attacking that in various different ways. Startups are like trying to solve problems in that space and trying to actually fundamentally kind of transform that space as we speak. A lot of the Gen AI revolution is because of large language models. And I'm sure everyone here, because you're quite a savvy audience, have heard of GPT 3.5 and of GPT-4, PaLM, Claude, and so on. And so if you look at LLMs today, what do we know about them? We know that they're super delightful. So if you have a question, they have some really, really insightful, interesting answers. They're really great for things like search. You actually, if you're like playing around with Google, you know that now you can actually go to Google, set a preference, and it'll actually generate, give you a generated AI response right up top. So it's actually integrated into search today, LLMs. They're great at not just generation of text, but they're great at generation of code, images, and so on. And when you go look at things like images, we're talking about other types of models like diffusion models and potentially generative adversarial networks. But the long story short is generally AI has been remarkably good at generation of everything from music to images to text. They're pretty delightful. They're great at search. They're great at information retrieval. Pretty much the only problem we've seen, I would say, with LLMs today is this ability it's this issue that they hallucinate. So every once in a while, every 1 in 10 times, they will make up stuff. So you just have to go back and validate that stuff. They can get things wrong. So that gets a little kind of like iffy. But beyond that, LLMs have shown a lot of promise in terms of actually generating text, generating code, and also being applied to various different use cases we'll just talk about. In terms of the models today, there are tons of different models produced by lots and lots of companies. In fact, we over at Abacus just released an open source model called Giraffe, if you want to check that out. And that is up on our Twitter page. That's up on my Twitter as well. So, we're in the Gen AI LLM space. The point being that tons and tons of different companies are creating very many different large language models. We've got Google, which was basically, I would say, in some ways, the pioneer behind these models. They published a paper a few years ago, I believe it was 2017, where they talked about the transformer architectures. The paper was titled "Attention is All You Need." And from there on, we started this revolution of large language models, which are based on these neural nets called transformers. And fundamentally, what these large language models do is they're trained on massive amounts of data. And as they get, as they get more and more data, they begin to kind of almost understand language in some way. So it looks like they understand language. And fundamentally, they're doing what's called next word prediction. So based on the words that they've seen so far, they're going to predict the next best word. And by doing that, it gets really good at answering or generating things. And in terms of the LLMs story, we've gone past Google. We have OpenAI, which actually came in with a big, big bang when they showed off their 3.5 GPT, which was really very performant. It could actually answer a lot of questions really well. It did a really good job. And so we have OpenAI, Google, we have Meta, which is Facebook, which has produced a lot of these open source models, as well as people like such as ourselves who have worked on these open source models and made them more effective, made them more enterprise friendly, and we'll talk about that a little bit. So in the Gen AI space, there is a little bit of a divide. The divide is between what I'm going to call closed source, or what the industry calls closed source, and open source models. Closed source models are models where you just have the API. You don't have access to the weights of the model. You can't run the model on your own. You just have to use the API in some way. These are models primarily right now from Google and OpenAI. OpenAI also offers these models as part of Azure. So these are, basically models which we don't know much about. We just have the API. We can use it. We can't really kind of modify it. And then there is an open source revolution which is going on. And the primary player in that open source world is been Facebook. Facebook has released these models called the Llama, models. So there's Llama 1, there's Llama 2, and there's talk about Llama 3 and Llama 4, which are very performant, which at times, if you can tune those models, they're as good as GPT 3.5, and honestly speaking, much better than the Google models. And these open source models have given us a lot of fodder to help people such as us, like Abacus and some other companies, basically try and modify these open source models to make them more performant for particular different tasks. What I predict is that over time, we're somewhere now closer to the axis to the left of this graph right now, where open source models are not as performant as closed source. I think it's well understood that GPT-4 is far and away one of the best large language models that we have. But the good news is the open source community is really working on things. And we are hearing rumors that Llama 3 is going to come out as well. And as we kind of modify, iterate, and make these open source models better, my bet is open source actually gets better than closed source models, because just traditionally, when you look at the arc of technology, that's been the case. Okay, how do these large language models work? I already talked a little bit about this. So far, historically, large language models have been about size. So the bigger the size, the more performant they are. I think that is going to change. We've actually seen some of that change with Llama 2 already. But fundamentally, what is happening here is these models are really huge neural networks with billions and sometimes trillions of parameters. They're trained on a large amount of data. And when you really brute force this simple idea of the next word prediction becomes very effective, because what the model is fundamentally learning is what is the next best word given a particular set of words. So as a typical problem or a typical way to intuitively grasp this is think of question and answers. If you see a question, what is the next word? It's the beginning of the answer, right? I mean, that seems very obvious. So if I said, who's the president of the United States of America? I think the answer, like Joe Biden, is quite clear. And that is somewhere in the training data. That's not that hard to figure out. And it's really simple for it to pull that Joe Biden out, because that's the next best word. And what it does basically is it goes into a loop, right? It first figures out Joe, and then it says, what's the next best president? Who's the current president of America? Joe. And then what's the next word? Biden. And that's very easy when you think about it in that context. And then it gets better and better because it is trained on that much amount of data. It's trained on, it learns all the latent patterns in language. The other thing to remember is these are language models. So in some ways, the concepts and the, patterns inside these models are invented by the human brain. And we have invented these concepts in a way that we can actually communicate with each other. So in some ways, it's recreating those concepts, recreating that communication, right? Okay, so that's how these LLMs are trained. Turns out that most of them are brute force. Turns out the bigger are better. Good news, as we're getting more and more, performant, as we're getting more and more open source development, what we're seeing is smaller models can achieve the same level of efficacy as really large models. So when you look at the Llama models that I just spoke about from Facebook, they're not that huge. So the biggest Llama model that we have, Llama 2 70B, it's a 70 billion parameter model. Turns out that it is as effective as GPT 3.5 in a lot of tasks. And GPT 3.5 is hundreds of billions of parameters. And that's really good news for kind of the AI community, for the open source community, for the startup ecosystem, because now you can start playing, toying, and hanging out with Llama 2. You don't have to go to 3.5. And then you actually have, the weights, the source that you can now modify, and that helps a lot. So having that ability to change things and have Llama 2 has been great. So, as I mentioned, best performing open source model. We did talk a little bit about how LLMs are trained, right? I told you about like how LLMs are trained based on a large amount of data. The other piece of LLM training that is really interesting, and a lot of few people have probably heard of this, is this idea of fine tuning the LLM based on human feedback. So there are two fundamental pieces to this whole LLM training. The first one is training it on a large amount of data. It's basically unsupervised, meaning it's just about a bunch of data, and the transformers are just learning kind of like the patterns in the data. The next piece is how do you get the LLM to behave? How do you make sure that it doesn't spout out hate speech? How do you make sure it doesn't just say random stuff? And this is the part where humans are involved. And here it's really simple. All this is all we're doing here is we're going to have a bunch of questions. It's going to give you some responses, or you can feed it some responses and say this is the right answer. And it over time basically you rate those responses. You basically take a good set of golden set of questions and answers, train the model on that, saying this is for this question, this is what's expected, right? And then you give it a whole bunch of other questions, and then it gives you answers. And then the human will come back and say, yes, this is a good answer or a bad answer. If it's a bad answer, you get you get no reward, or you get negative reward. Good answer, you get good reward. You score that. You go back and do multiple iterations of this fine tuning. And as you fine tune the model becomes more and more disciplined. It gets you can actually make it do things like not spout hate speech, or it can. I mean, the classic thing is it might say, "Hey, I'm a large language model. I'm not going to answer this question because it's a controversial question." And that whole piece is called RLHF, which is reinforcement learning based on human feedback, and that is sits on top of the these pre-trained models. So now that we have Llama 1 and Llama 2, what has happened is there are tons and tons of people who are now working on top of Llama 1 and 2. And so what we do, like, for example, what Abacus has done to a great extent, and you can use the Abacus platform for this, is we will actually fine-tune Llama, meaning we will further kind of retrain Llama and create kind of specific fine-tunes for specific tasks. Like, so can we get Llama to actually really behave very well for question and answering? And we have a really good Q&A model for like enterprise data sets. And so you can actually fine-tune these large language models. And the way you fine-tune them is also you use evaluation, this is kind of clever. You basically fine-tune them and then get them to respond. And we assume GPT-4 is the gold standard to some extent, and we see how well they do compared to GPT-4. Or you can even ask GPT-4 to respond and say whether this is a good answer or a bad answer, right? So there's a bunch of different ways you can actually kind of not just fine-tune these models, but you can also evaluate their performance. So the open source community as well as the LLM community has come up with a different bunch of frameworks where you can actually look at various different tasks that the large language model can perform. So it could be natural language understanding, and now even reasoning. So LLMs are actually pretty good at reasoning capabilities, which has really surprised people. But now you can actually define like these benchmarks, which are let's think about them as a golden set of desired answers or desired responses, and then you can compare your large language model to these benchmarks. And there's a ton of these benchmarks right now that you can use. There's a bunch of ways you can actually start comparing performance on these different tasks on these different data sets. And again, this is fundamentally how research in the AI community has worked before. So it's good to see that happening with LLMs as well, which is you will see over time people developing new algorithms, new models, new approaches. And then we have these benchmarks that everybody more or less agrees upon. And then we can compare and contrast our models, our techniques, and our algorithms on these benchmarks. Because it's a new field, there's many ways to evaluate these LLMs today. There are people who are looking at LLM assisted benchmarks. That's one of the most exciting fields right down there, which is basically GPT-4 is evaluating the results, or that is considered the gold standard. And then you basically see how close you are to those results. You can also look at other types where you're just looking at, what is my desired answer and how far are you from that desired answer. So you can actually get distances between desired answers. You can also look at other scores, like, there's a BERT score, which is based on the embeddings of your LLM. So there's different ways you can evaluate these LLMs. And as I talked to you before, if you look at these LLM-assisted evaluation methods, where you're basically looking at GPT-4, being able to generate the questions and sometimes also generate the right answers for it, then you can actually have GPT-4 rate the quality of answers too. So in this particular evaluation that they've done, we're basically having GPT-4 rate the quality of their answers based on helpfulness, relevance, accuracy, and detail. So it produces a bunch of challenge questions. Then it looks at the answers. It kind of evaluates it, and so you're seeing the GPT-4 being the judge, which I think is kind of clever. And you will see the good news with all of this evaluation, the benchmarks, the open source models, the closed source models, is that open source models are really catching up to closed source models. The point I'm trying to make so far is LLMs are great. They have lots of uses. Closed source models have been the best so far, but open source is really catching up. And there's a lot of activity in the open source world. And this comparison is a little outdated. It's on 13B Llama. And if you look at the newer ones with LLM, Llama 2, 70B, it's really good. So 70B can be very good. We really can come up to chat GPT levels in some sense, especially 3.5. Again, GPT-4 is a generation ahead, but we're trying to catch up to 3.5, which is actually a very commonly used model right now because 4 is very, very expensive. So a lot of people don't use GPT-4 because of that. They all use 3.5. 3.5 is very affordable and pretty good. So you don't really need to go to 4 if you don't have to. Okay, let's talk about common sense reasoning. This is the idea of actually having the LLM make logical decisions, right? If there are 3 red balls, I take out 2 white balls. If I had 2 blue balls, how many balls do I have? / how many colored balls do I have? So anything which involves logic and reasoning, it's one thing to generate answers by just in some ways, just looking at patterns, memorizing these patterns, looking at large amounts of data. But it's another thing to be able to reason. And it turns out that a lot of these LLMs have shown what is called emergent properties, meaning they're able to reason, and people are pretty delighted by their ability to reason. Again, there's a lot of different benchmarks. The things that you see on top here are the various different benchmarks or evaluation methodologies or evaluation data sets, which people have produced over time. And then you see how each of these large language models compare to those evaluation data sets. Again, you see Llama there, and this is Llama 1, by the way. So Llama 2 is strictly better than this. Is actually really is really good at reasoning as well. So again, we are seeing that big, kind of rise in open source models, them doing really well. Here is the Llama 2 score. This came out. I mean, I put this deck together just a couple of weeks ago, and this came out, and you can see that in a lot of these benchmarks, these things are doing pretty well. These models. Okay. So now that we've got, understood large language models, we've understood open source versus closed source, the next big thing is what is called the context length. Okay, so what does that mean? So if you have your own knowledge base, if you have your own data, so imagine if you have 1 million documents sitting internally on your intranet, and now let's say you want to create a custom chat GPT on top of that intranet. How do you do that? Well, the issue right now is you can't really, the LLM, whether it's Llama 2, whether it's Abacus' Giraffe, whether it's Vicuna, whatever, it doesn't know about these 1 million documents, right? It doesn't know about your internal documents. So what happens, or what we generally do in that case, is we basically send the LLM some piece of your knowledge, meaning we take, let's say, 1 or 2 of those documents from those 1 million, send it to the LLM in a real-time API call, and then give it a question and say, hey, the answer is somewhere in these 2 documents. Find the answer, create a good response, and respond back. So that's a typical LLM API call when it comes to internal knowledge bases. The catch is you can't send all the million documents. You can only send, some number of documents, and that is now restricted on something called, tokens. And this, you only can send about 32,000 tokens at one point in time. And even the 32,000 tokens wasn't possible on open source LLMs till last week. We released Giraffe. That is, Abacus released this fine-tune on Llama 2 called Giraffe, where now you can send that 32K context. I think I've seen one or two more models which are able to do that, but we're really in the beginning of this. So we're very proud to have released one of the world's first models, which will take at least 32K. Now, again, why this is important is the bigger that number, if it's 32 versus 8 versus 2, the more information you can send. The more information you can send, the more performant your answer. Does that make sense? You want the as much information to be sent to the LLM. Otherwise, it just doesn't know, how to answer it, or maybe the answer isn't there in the information you sent it. Okay, so now we've basically established kind of an issue here with these LLMs, which is that you have to send the right information for it to generate the answer on your custom chat GPT. So if you're building your own knowledge base, you're building your own GPT. I like to call it the AI brain for your organization. So if you're building an AI brain for your organization, which you should be, if you aren't, you have to use this context length is limited. Okay. Now that we know that context length is limited, now what? So what happens now is people put together a bunch of different modules. So it's not as simple as, okay, I'm just going to turn on this LLM, it's going to work for me. No, because we have this context length issue, because your data is all over the place, right? No enterprise has the data in one place. They have their data in Word documents and SharePoint and Google and whatever. And so what you need is really a complete end-to-end LLM ops system. So you need something which pulls all these together. You need to get all your data together. You need to create some sort of search index. And the search index basically tries to get you those 2 documents from the million, right? So the idea is to pull the 2 documents which have the answer, take those 2 documents, send it to the LLM, get the response back, and then show the user the response. And all of this has to be orchestrated, to create an actual conversation. So this is not just one Q&A. Usually, if you use ChatGPT, you know this, it's an ongoing conversation with the LLM. So the LLM needs to have all the data at all times. So imagine I asked a question, now I ask a follow-up question. We need to know whether the 2 documents we sent on the first question has the follow-up answer, or there are 2 more documents to get. So there's a lot of orchestration. So basically, this is turning out to be pretty hard. You have to have your LLM, you have to have your data, you have to have process the data, you have to have a search index, you have to have an orchestrator, you have to keep track of the history. And on top of all that, you need an interface which is similar to ChatGPT, ideally, if not better. And so that's where we come in, where Abacus.AI right now has a solution called Chat LLM. You can build your own custom ChatGPT on your custom data. You can connect to your Confluence, your Slack, your Google Drive, your S3, what have you. We bring all the data together. We process all the data, create the search index. Also, you can use any LLM. So no longer is it one LLM. You can use, Google. You can use Claude. You can use open source. You can use Abacus's Giraffe. You can use OpenAI. So you can pick and choose the best LLM that works for you. So long story short, in order to build these, end-to-end kind of AI brains for your organization, or the custom chat GPT for your organization, you need this LLM ops platform. It's got a lot of painful pieces to it. Just OpenAI will not work. You need these, doc retrievers or these search indexes. They're called vector databases sometimes. And Abacus hosts the whole thing. We have vector databases, we have doc retrievers, we have PDF connectors. We bring in the data, we help you transform the data, we create that search index or the vector data store, and we help you on top of it to compare and contrast all your LLMs. And you all want to do this in one place. It's a very bad idea, supremely bad idea, to try different vendors in different places. You go buy a vector store from place A and use an LLM from place B, you're already in big trouble, because you now have to create that orchestration layer on top of the vector store and top of that LLM, which, what the nightmare will just continue. So my recommendation strongly is to look for these end-to-end LLM and MLOps platforms, which can do the whole thing. It's not even worth it. You're doing everything that everybody else is doing. There's nothing new, nothing great. And I would just give up. Just let the machine do it. So you do need to have that complete LLM ops platform. Again, a lot of the cloud vendors have this. Abacus has it. And you're looking for things where you do most of the thinking work and not the heavy lifting. If you're going to be recreating the ChatGPT interface for the 1 millionth time in your organization, you're probably failing. So you don't want to do that, right? You want to be able to use an interface. You want to be able to use existing structure, build on top of it, not basically recreate what everybody else has done a millionth time over. Again, this is a pictorial representation of how this works. You can use Abacus LLMs, you can use OpenAI, you can use what have you. Then the key part here is the interface. And people don't understand how important this interface is. If you don't have that interface, then who are your users? They're not going to use it. So what Abacus has is this really state-of-the-art interface, which is as good, if not better, than OpenAI's. The reason it's better is we not only give you the question answers, we not only give you the threading, the history, the whole enchilada, but we also tell you where the answers are from. Like, tells you exactly which place the answer is coming from, which is very important in the enterprise AI context. You can also leave feedback. You can have your own users. It's completely fully featured. And then finally, that's not just it. We want to be able to send that information to you on your Slack or Teams. So what if you don't want to use the interface and just want to use Slack or Teams? Or what if you want to use the interface every once in a while and use Slack or Teams every other time? You want to be able to have that seamless integration across all these places so your employees have access to all the data. Then what if you want to draw charts? What if you want to write code? This interface helps you do all of that. It also helps you get data and show you that data. So long story short, you can use LLM APIs. You can use your own base model. This does tend to be better than GPT-4. Why? Because we have that doc retriever, we have that orchestration layer, and so the quality is really good. We can also have the LLM, an Abacus LLM inside your VPC. So a lot of people are like, I don't want to use OpenAI. I have some issues. I don't want to go outside my cloud, right? I don't even want to go to some other cloud. In which case, we can actually install the whole thing inside your VPC. There's one more reason why we can be better quality than GPT-4. We can fine-tune these LLMs, meaning we can take your data and instead of even using the doc retriever, sometimes you can fine tune it and we can, talk to you. We have a free consultation. You can come chat with us. The other piece I just want to touch on before we, stop for, or before we conclude is AI agents. The difference between AI agents and chat LLM is very simple. With AI agents, you want to do much more than chat. You just don't want to, chat is one thing. Like, okay, fine, I'm chatting about something or I'm chatting about a document. I'm chatting about my contracts. That's a use case. But what if you want to generate code? Or what if you want to classify documents? Or what if you want to summarize documents as they come in? What if you want to do search? And that's where agents come into play. And fundamentally, when you think about agents, here's what we're thinking about. You want to be able to orchestrate a bunch of different functions. Think of it this way. You want to be able to transform any piece of data. You want to be able to write a function which has any piece of code. You want to be able to call out to any machine learning model. Now, large language models can only work on language. What about if you have a structured data model? What about if you have a forecasting model? So you want to be able to work on any ML model, and you want to be able to orchestrate a large language prompt. So if you have a sequence of things, like go grab my data, run this code, call this model out, talk to the LLM, get the summary, a bunch of things, we've got what's called agents. Agents help you build these large language applications really quickly. You can use LLM in the backend. You can fine-tune those LLMs just like I spoke about. But most importantly, you can chain these blocks together. Chain a data processing block with a code block, with a LLM block, and then come back to an LLM. So it basically allows you to do your own thing, like build your own agent in any which way. Right. So again, Abacus has a fully featured agent platform. Part of that is we've worked on this for the last 5 years. We have a great MLOps platform where you can do all kinds of data transformation, where you can do all kinds of code processing. You can run your code. You can monitor it. You can monitor like versions. You can monitor data set versions. If you don't have any of that, this is all not going to work anyway. And so you need those pieces. You need the connectors to data sources. You need the transformations. You need the LLMs. And if you have all of those pieces, it gets much easier. One of the most common agents that we've seen is what's called a data LLM. A data LLM works on your database or your data source, and it understands the underlying data structure of your database. And what it's doing is it's basically acting as a reporting tool or a way for you to get insights from your data. So you can ask things like how many users like signed up in Jan and how many of those users churned out in March. Let's say that was your question. What do you do today? You go to your Tableau dashboard, you go talk to a data analyst, you go talk to like a looker person, whatever you're using today, you probably go use that. Millions and billions of dollars for the software, even more money for like, spending on your data analysts. Instead, what you can now have is a data LLM. And what data LLM does is the LLM gives you the answer almost immediately. Like you can literally type that question out and you get the answer. Well, to be fair, it's not immediate because it has to execute the code on the underlying database. But the way data LLMs work is it takes a question, it understands your data, it creates a SQL query or a data query on the data source. It runs that on your data source, responds back, and then the LLM summarizes it. So it's a very powerful way of actually creating things. Finally, let me end by saying Abacus itself can be programmed using a generative AI model. And that's what we do. We have something called AI assisted data science, where the data scientist really isn't building the models or really isn't doing the data wrangling. They're telling the AI to do so. So you can actually literally talk to AI chatbot, get all these, get them to do the data transformations, get them to do data wrangling, put this in production. And for that, we have something called AI chat. So that's the last piece. Chat LLM, AI agents, and AI chat. These we think are going to revolutionize the way machine learning and data science is done. AI chat basically actually will execute your code, your model, your anything on our platform. So you can literally say, hey, go train a forecasting model on this data. It'll actually not only process and clean the data, but it'll also train multiple different forecasting algorithms, including ones invented by us, and then pick the right model for you. So we think this is the future of data science. So there you go. Abacus gives you all the pieces to build large-scale AI agents and systems. Thank you. That concludes my talk.